I am recording. I'm going to begin by sharing my browser with you just to show you where we are. And you can see that we're still in week 14. And we did the area, volume, and average value last time. And today we're going to be talking about applications to business. Okay, here's the background material. And these are the notes that I'm going to be using. Okay, so if you give me a moment, I'll get those notes open and I'll share them with you. Okay, let's share that content. Okay, everybody should be seeing then 3.7 integration applications to business. And I'll get the chat open in case anybody has comments. Okay, and again, I'd encourage you to just speak up if you've got comments or anything while we're moving along. Okay, so what we're going to be talking about today in applications of business is two things in particular. The first thing is called consumer and producer surplus. This concept is about 170 years old. I believe it was developed around 1840, 1850. And the idea was to try to value the benefit to consumers of public goods like, roadways and bridges, things like that. And it's based on a concept called marginal utility that says the individual consumer's satisfaction um, is what he gains from consuming one more unit of whatever the product is. And I'm sure, figuring out what the units are for your satisfaction probably was an interesting process. But that's based on what, that's basically what this is, the idea of utility of common goods. Okay, so we're going to start out with supply and demand. Again, this is an economics concept. Okay, and you can see what I have here is I have a blue demand curve. Okay, so this curve here is my demand curve. And I have a red supply curve. Okay, and take a note of what's on the axes. Okay, this is quantity down here on my horizontal axis. And here's P, price in dollars per unit. Okay, now the idea, I'm going to put a little statement in the chat, okay, about supply and demand. Okay, so basically the idea of supply and demand, it's a relationship between the price of a given good or product and people's willingness to either buy it or sell it. And you can see over here on the demand curve, okay, basically demand, the quantity demanded is going to be pretty low. It's near zero here when the price is high, okay? And basically on the supply curve, you can see the quantity people are willing to supply when the price is high is very high, okay? So think of it like that, okay? Remember, these are low values over here. You can put a zero here to kind of give you an idea, okay? Here's quantity demanded or supplied, and these are the prices, okay? So hopefully everybody is at least comfortable with this idea of supply and demand, even if you haven't seen these curves before. But it turns out the curves are going to be important to us because we're going to be integrating to find the area underneath them, okay? And so let's take a look at this concept called equilibrium point. Okay, the point at which the supply and the demand curves cross is called your equilibrium point right here. Okay, and usually the quantity Q star is called your equilibrium quantity. Okay, and P star is your equilibrium price. And again, the idea of equilibrium is when things are in balance, right? You can think of this as the price and the quantity where supply and demand are kind of balanced out. Okay, this is kind of like the sweet spot right here. Okay, anybody questions about these curves before we move on? Anybody? Because again, I kind of got the impression from, our interactions in class that maybe a lot of folks haven't taken econ classes. Okay, anybody? All right. Now, of course, you'll notice this green line, okay, that goes through the equilibrium point right here, okay? And you'll notice that they've shaded this area below this green line, pink, and they're calling it producer's surplus, okay? And they're shading this area above the green line that goes through the equilibrium point, blue, and they're calling it consumer surplus. Okay, so here's the idea. Okay, if your price is set at your equilibrium price, so your quantity demanded equals the quantity supplied, then consumers here in the blue area, okay, would have been willing to pay a higher price. Do you see how they're above the P star line? This is the vertical line that the horizontal line that corresponds to P star. So these consumers actually would have been willing to pay more for the good, okay, above the equilibrium price. So you can kind of think that this surplus, okay, is what buying at equilibrium price has saved them. Okay, so they've saved money by buying at equilibrium price, and that to them is a surplus. Okay, similarly, right, producers down here, okay, here's equilibrium price, the green line, okay, and you can see they would have been willing to supply the good at a lesser price. So selling at equilibrium price actually made them money. Okay, so this is kind of like the difference between equilibrium price, okay, and the supply price. This is the difference between equilibrium price and the demand price. Okay, so essentially anything in these shaded areas would accrue as a savings or a surplus to either the producer, okay, if we're talking about the supply side, or the consumer if we're talking about the demand side. So does this make logical sense to you? Okay, does this make sense? Anybody have questions about why these would be called surpluses? Okay, it's really important with these economic models for it to make sense. Otherwise, it's real easy to get lost in the weeds. Okay. So again, what you want to remember is this green horizontal line is P star. Okay, because remember, price is on your vertical axis. Right? So difference between supply price, equilibrium price, difference between equilibrium price and demanded price. Okay, so in order to calculate consumer surplus and producer surplus, you can see if you put your calculus hat on now, you can see this is just going to involve finding the area between two curves. And one of them is going to be a horizontal line, so that's going to be easy. Okay, so to find the pink area, okay, I want to find the area between P star and my supply curve. To find the blue area, I want to find the area between my demand curve and P star. Okay, so again, the order that the two curves will be in the integral will be a little bit different. But again, if you have this picture in mind, you'll be able to do it correctly. Because remember, you always want the higher curve, the one that's on top, to come first when you're finding area between. So it's top curve minus bottom curve. Okay, so here you'd have demand curve minus P star. And for the pink part, you'd have P star minus supply curve, because the supply curve's underneath P star. Okay, so that's kind of where we're going to go with this. And then the rest of it is just cranking through the integration. All right, so here's the next page. And I kind of explained all this before, okay? You know, why each group has a surplus, okay? Being willing to either supply the goods at a lower price or would be willing to pay more for their goods demanded, okay? So let's work on consumer surplus first, okay? And again, that's the blue area, the blue shaded area on the graph between my demand curve and P star. So again, you can see all I'm doing here is using a definite integral to find the difference between my demand function and P star, right? This one's going to be the one on top, and this is going to be the one on the bottom of the blue area. And if we also look at the blue area, you can see that on my horizontal axis, this goes down to Q star, right? That's what that equilibrium point means. So if I want to find this area here, I'm going to integrate from Q equals 0 out to Q star, okay? Because that's as far as this blue area goes to the right, all right? And then it's top curve, which is D of Q minus bottom curve, which is P star. And that's how I got this integral right here. We're always going to be integrating with respect to Q, so you make sure you put a dq. Okay. Now, since you've got two separate terms here, you can split this up into two separate integrals. Okay, you can integrate the demand curve with respect to Q and integrate P star with respect to Q. This is a super easy integral to evaluate because P star is a constant. Okay, so if you integrate this with respect to Q, okay, and evaluate it at Q star, you're going to just get minus P star Q star. Okay, so in other words, you can think of the integral happening like this. Okay, you do the integration first and you get P star Q, and then you want to evaluate that from 0 to Q star. So what does that give you? That gives you P star Q star minus P star times 0. Okay, and that's just P star Q star. So that's how they got from this integral down to this set of this product of two constants. Okay, so I'm just showing you where it came from. Okay, but they actually did an integration here. A Q popped into existence, and then they evaluated at the upper bound minus the lower bound. Okay, the lower bound gave them a 0, so they just got the value at the upper bound. Okay, so essentially, this is your formula for consumer surplus. Okay, this is how we're going to use it. And again, there's a little yellow box that has the formulas in it, so you can always refer to that. But before I move on, let me ask, does consumer surplus make sense? Everybody all right with that? Does consumer surplus make sense? Okay, we're just integrating between two curves, and this second integral simplifies out to just a product of equilibrium price times equilibrium quantity. And again, remember what these are. Okay, so all you're doing is integrating the demand curve, okay, and then evaluating that between these bounds. Okay. Similarly, if you back and look at the pink area on our graph, you can see that also is from 0 to Q star on your Q axis. But this time, your equilibrium price is the top curve. P star is on top. So you're going to do P star minus your supply equation, and you're going to integrate that. Okay, P star comes first this time because it's the top curve. Okay, and you can see that right here. P star minus S of Q dq, and integrated from 0 to the equilibrium quantity. All right. By a similar mechanism, they're going to split this into two integrals. They're not showing it. Okay, and they're going to integrate the first one, and they're going to get P star Q star minus the integral, the definite integral, okay, of the supply curve. Okay, so again, they're not showing all these steps for this. So when you're all said and done, here's what you wind up with. Okay, so you have to be given a demand and a supply function and an equilibrium point, or at least enough information to figure it out. Okay, so then you've got consumer surplus here and producer surplus here. Okay, if you add these two together, you get something called the total gains from trade. All right, so again, it's what everybody saves by trading at equilibrium price. Okay, so this yellow box is just a summary of all of the work that we've done up to this point. Okay, just so people can see it all in one place. But again, I'm showing you the work just so you have some idea of where this stuff came from. Okay, it's based on finding the area between two curves. Okay, that's all it is. Okay, so producer surplus is very similar. Only difference is equilibrium price times quantity comes first instead of second. Alrighty, so let's take a look. Okay, you might say, what units might this be in? Okay, area, remember these are area units. Okay, so you have to multiply the units on the horizontal axis times the vertical axis. And they told you that the price was in dollars per item. Okay, and you know that the Q units are in quantity of items. So you basically have item times dollars per item. Okay, and you can see item cancels out. So this surplus is going to be in dollars. Okay, if we're measuring our monetary units in dollars, I mean, it works with yuan and euros and whatever. Okay, but basically that's what I'm trying to say here. Okay, if you're ever concerned about what the units are on a definite integral, go back and look at your graph. Okay, and take a look at what's on each of these axes. Okay, this is in dollars per unit, and this is quantity in units. So your area would be price, right? The price units times the quantity units. Unit cancels out, and you wind up with dollars. Okay, so again, that's important to remember, particularly when you're talking about an applied problem. Okay, so let's look at a couple of examples with this. Okay, they're giving us a demand function D of Q and a supply function S of Q. Okay. Now they want us to know, they want us to figure out what's equilibrium quantity and equilibrium price. Now remember I said this is where your quantity demanded equals your quantity supplied. So it's where S of Q equals D of Q. All right. So essentially, they gave you the two equations. All you need to do is set them equal to each other. So there's my demand equation, and here's my supply equation. Okay, so I'm basically setting them equal to each other. Okay, and then I'm going to solve for Q. actually for Q star. Okay, everybody all right with this? This isn't calculus, this is just algebra. Okay, and it requires that you know what equilibrium means. Okay, it means supply equals demand. Okay, all right, so I've set the two equations equal to each other. Now I'm stuck doing some algebra. I want to get that square root of Q out of the denominator. So I'm going to multiply both sides of the equation by the square root of Q. Okay, and I think everybody will agree this cancels out. Now I have 4,500 equals 5. And what's square root of Q times square root of Q? What's this? How can I simplify that? Anybody have any? Okay. Well, again, remember with the product, what are you going to do with the exponents? Okay. When multiplying, add the exponents. Okay. So essentially, I'm not going to multiply the exponents here. I'm going to add them. All right. So this is like 5 times q to the 1/2 times q to the 1/2. Okay, because square root is the 1/2 power. So that's 5 times q to the 1/2 plus 1/2, which is 5 times q to the first. Okay. Again, if you take a square root and you multiply it by itself, you're essentially squaring the square root. So the squaring and the square root undo each other, or you can look at adding the exponents like this, and you're just going to get 5q. Okay, everybody okay with that little bit of algebra? Okay. Anybody have questions about that? Okay. All right, well, now I got a simple linear equation. The first thing I'm going to do is divide by 5. Okay, that's going to give me 900 equals Q. Okay, and that's Q star, my equilibrium quantity. They also asked me to find the equilibrium price. Okay, so now what I can do is I can substitute Q equals 900 in either the supply or demand equation, right? Because again, at equilibrium quantity, both of those equations are going to yield the same price for the product. That's what equilibrium means. Okay, so I'm going to choose what I think is the easier one, which is S of Q equals 5 times the square root of Q, and I'm going to put in 900 there. S of 900 equals 5 times the square root of 900. Okay, square root of 900 is 30. So this is 5 times 30, which is 150. Okay, so basically, I have my equilibrium quantity is 900 and my equilibrium price is $150. Okay. Everybody all right with part A? Okay with part A? Okay, and again, remember both S and D, both of those functions give you a price. Okay, so this is a price. Yeah, questions, folks? Again, I'm trying to go a little bit slower only because I know this is probably not common knowledge and I don't want to lose you with what I'm doing. Okay, so long story short, set supply and demand equal, solve for Q, put Q back into either equation to solve for P. Okay, that's what I did. All right, now to find my consumer's surplus, okay, I have this function, this integral rather, from 0 to Q star. And that's the one where I have my demand function first, minus, oh, this is dq rather, minus the product of equilibrium price times quantity. Okay, and again, I'm going to highlight my equilibrium price and quantity just so they kind of pop out at me. Okay, I don't have to go looking for them. All right, so this integral would be the integral from 0 to my Q star, which is 900. Okay, and then I have my demand equation, which again, if I look up here, is 4,500 over square root of Q. dq. And then minus P star times Q star. Okay, so that's this integral with everything plugged in. Okay, here's P star, here's Q star, here's my demand equation, and here's Q star up here is the upper bound on the integral. So it's just a matter of having the formula handy and plugging in the right numbers. Okay. Now, what I might want to do is simplify stuff a little before I get rolling with the integration. Okay, so I'm just going to rewrite this one more time, 0 to 900. Okay, I don't like the square root of Q in the denominator, so I'm going to write it like this, times Q to the minus 1/2, right? It's 1/2 because it's a square root, and it's a negative 1/2 because it was in a denominator. And then you can just multiply the 150 and the 900 together to get 135,000. Okay, so I've kind of simplified two things. These two numbers give me the 135,000, and I took square root of Q out of the denominator and wrote it as Q to the minus 1/2. Okay, please understand this constant is not part of the integral. Okay, so not part of the integral. Okay, it's just I'm going to be getting a definite integral, which is a number out of this part, right? Because it has bounds on the integration side. And then whatever number I get, I'm going to subtract 135,000 from it. Okay, this is not part of the integral, and you can tell that because the dq comes before it. All right, so here's your integral right here. Okay, it's just part of the formula for consumer surplus. Okay, since this is just a variable to a power, we're integrating with respect to Q, I'm going to use the power rule on it. First, I'm going to pull through the 4,500. So I have 4,500 out in front. Okay, and then I'm going to add 1 to the exponent. So if I have negative 1/2 and I add 1, I'm going to wind up with positive 1/2. And that's over the new exponent. And that gets evaluated from 0 to 900. Okay, so that's the sum of the integration. Let me not lose the minus 135,000. Okay. So this is the calculus part, right? I just used the power rule. First, I pulled through the 4,500. That doesn't factor into the integration at all. And then I added 1 to this exponent to make it positive 1/2, wrote it over positive 1/2. Okay, the rest is algebra. Before I actually evaluate my definite integral at the two bounds, I'm going to get rid of the 1/2 in the denominator, and I'm going to do that like this. 4,500 divide by 1/2 is the same as multiply by 2 over 1. And then I have q to the 1/2 from 0 to 900 minus 135,000. Okay, so this is just algebra. I'm changing divide by 1/2 to multiply by its reciprocal. Okay. Now what that lets me do is it lets me multiply these two numbers together to get 9,000. Okay, and now I'm going to do the upper minus lower, okay, according to the fundamental theorem of calculus. Okay, so I'm just putting in q to the 1/2, so that's 900 to the 1/2 minus 0 to the 1/2 minus 135,000. Okay, and basically this is just a square root. Okay, so square root of 900 minus square root of 0. I know this is 0. Okay, so now I'm to the point where I can do this on a calculator. This is the part that you use a calculator for. So I'm going to share my TI with you. Okay, and I'm just going to type that in. So I have 9,000 times 900 to the 1/2. Okay, minus 0 to the 1/2. And again, I do realize you can do a lot of this in your head. If you're so inclined, that's fine. I'm just showing that you can get it without doing it that way. Okay, so here's upper minus lower. That 9,000 out front applies to both of those numbers. And then I have minus 135,000. And you can see I get 135,000 as the value of the consumer surplus. Okay, so my consumer surplus is 135,000. And again, that means the consumer saved $135,000 by buying at equilibrium price because they would have been willing to pay more for it. Okay. Anybody questions on part B? Are we okay with part B? Okay with part B? Anybody questions on this at all? Okay, the trickiest thing about doing these surpluses is don't lose the product of equilibrium price and quantity. It's real easy to get so caught up in doing the integration that you forget about it. So notice every time I rewrote my integral, I made sure to write that minus 135,000. Okay, don't lose it. Okay, well, let's try then producer surplus, which is a really similar equation. Okay, that's P star Q star first minus the integral from 0 to Q star of the supply equation with respect to Q. Okay, so there's producer surplus. Okay, again, all the stuff here is on the same page. Here's my P star and my Q star, and there's my supply equation up there. Okay, so I'm going to just plug everything in. That's from 0 to 900. Oops, let me not lose the beginning. Okay, so it's 150 times 900 first. So P star times Q star. Then the integral from 0 to 900 of the supply equation, which I'm going to write as 5Q to the 1/2 dQ. Okay, the supply equation is 5 times the square root of Q, and I'm just writing it with an exponent to make the integration easier to do with a power rule. Okay, so again, here's P star, Q star, here's another Q star up here as your upper bound, and here's the supply equation. Okay, so just to simplify things a little, I'm going to first have my 135,000 here minus, okay, then my bounds on my integral. One thing I could do before I do the integration is I can pull through that 5 as a coefficient. And now all I'm integrating is Q to the 1/2 dQ. Okay, so you can pull through all of your coefficients before you get started. Okay, now to do the integral, to do the antiderivative part, I'm just going to add 1 to the exponent 1/2. That's going to give me 3/2. So here's what I get after I do the integration. I have 135,000 minus 5 times Q to the 3/2 over 3/2, evaluated from 0 to 900. Okay, so there's the integration piece. Okay, and I just used the power rule on this. Okay. Now I'm going to do a little algebra before I evaluate. So here's 135,000. Again, I'm making sure I don't lose that. Then this is minus 5, and instead of divide by 3/2, that's multiply by 2/3, Q to the 3/2 from 0 to 900. Okay. If you want to rewrite it one more time, just to simplify things, and again, you can combine steps, as long as you can combine steps and not lose track of what you're doing. 5 times 2/3 is 10 on top, thirds, Q to the 3/2 from 0 to 900. Okay, so now when I actually evaluate the integral at the upper and lower bounds, I'm going to do it this way. I'm going to take out the 135,000. Okay, and I'm going to write 10/3 on the outside of what I'm going to evaluate here. And that's going to be upper minus lower. Okay, and then I have Q to the 3/2, and my Q value is 900 to the 3/2 minus 0 to the 3/2. Okay, and here again, I have a calculator problem. Okay, so I'm just going to type that in. And again, it won't let me keep snapping the calculator over there. So I'm just going to reposition things. Okay, and now I have 135,000 minus 10/3, and I can write it like this: 10 divided by 3, open parentheses, 900 raised to the 3/2 power minus 0 raised to the 3/2 power. By the way, 0 to any power 0. Okay, except 0 to the 0, I'm not sure about that. I think that's an indeterminate form. Okay, so there's what I'm typing in. Right, I hit enter, and I get $45,000. All right, so this is my producer's surplus. And this is what Producers saved by selling at equilibrium price because they would have been willing to sell lower. Okay, so you can think of that as the money they made by selling at equilibrium price. Okay, anybody okay? Is everybody okay with part C? Everybody okay with C? Anybody got questions on anything in this problem? Okay, so pretty much all we're doing is taking what we already know about doing definite integrals and applying it to find the area between these two curves. Okay, so we're not really learning anything new about calculus, but maybe we're learning something new about economics and how to apply it. Okay, I'm not seeing questions. I'm not really seeing any kind of comments, so I'm assuming you guys are okay with this. All right, there are 8 of you on. All right, so let's take a look at this one. Okay, and let me ask you a question. Okay, how would you go about doing this? They're saying they're giving you a demand function and they want you to find the consumer's surplus corresponding to Q equals 750 units. Okay, so I'll give you a hint. This is Q star. Okay, what do you do first here? Somebody explain in words. What do you do first here? Anybody have any thoughts? Okay, think about what you need in order to use the consumer surplus formula. Here's the consumer surplus formula. Okay, there's your consumer's surplus formula. Okay, what do you need in order to make this go? Do you have everything you need? Okay, yeah, you need P star. Good for you, Richard. P star. Okay, see P star here? You've got Q star, and they gave you D of Q. Okay, how do you get it? How do you get P star? Oh, geez. How do you get P star? It's a logic question, not really a math one. Well, remember what the supply and demand equations give you as an output. Okay, they give you a price. Okay, so if you've got a Q value, all you need to do is plug it into the demand equation to figure out what P star is. So D of 750 equals negative 0.02 750 plus 40. Okay, so that's going to give me P star. Okay, once I figure it out. Okay, and again, this is a calculator problem. So just fire up the calculator and I say negative 0.02 times 750 plus 40. That gives me 25. Okay, so P star is 25. Okay, so now you've got your Q star and your P star. Okay, so why don't you try figuring out the consumer surplus? Okay, you do that part and then type done when you finish. Okay, so you try this piece. Okay, you figure out the consumer surplus. Now you have all the pieces you need. Okay, we'll take like about 5 minutes to do this. We'll take another minute on this, folks. Okay, folks, let's come together. I'm guessing that maybe some of you got stuck with this problem. Okay, is that true? Did you get stuck somewhere? Anybody get stuck somewhere? Okay. Well, let's go through it step by step. I know some of you are probably still working, and that's okay. But let's just go through it step by step to make sure you understand the process. Okay, first thing I'm going to do is take my consumer surplus equation here, and I'm going to plug in the values that I know. Whoops. So that is going to be from 0 to my Q star is 750. So that's my upper bound on the integral. Okay, and then I put in my demand equation, which is negative 0.02 Q plus 40 dq. Okay, and then I'm going to subtract P star times Q star. So that's 25 times 750. All right, so there it is with everything plugged in. Okay, I really don't need to do any fixing up with this expression here because, again, it's a polynomial. The exponent on Q is a 1, so it's going to be real easy to integrate. Okay, the only thing I can think of is if I wanted to rewrite this product as a number, it would be 18,750. But I'll just make a note of that. Okay, so the next time I write it down, I'll just write the product. Okay, so let's integrate. Okay, I'm going to first, with the first term, I'm going to pull through my negative 0.02. And then I'm going to use the power rule on Q. So I'm going to add 1 to the exponent, write it over the new exponent. And the same thing with the second term with the 40. Remember, that's like 40Q to the 0. So if I add 1 to the 0, I'm going to get Q to the first over 1. So a Q pops into existence here. Okay. And then that goes from 0 to 750 minus 18,750. Everybody okay with the integration part? Anybody questions about the integral? Okay. Makes sense? Good. All right, so before I actually evaluate it at the bounds, you see this 2 on the bottom and this 2 on the top. I'm going to clean that up a little, okay, before I evaluate. So I'm going to divide 2 here and 2 here, and I'm going to get negative 0.01 Q squared plus 40Q, evaluated from 0 to 750 minus 18,750. You'll notice that I typically do my algebra steps before I do anything related to calculus to try to get things as simple as I can before I start making them complicated again. So now I'm going to do the evaluation at the upper and lower bounds. So upper minus lower, okay, over here. And that's going to be negative 0.01 times 750 squared plus 40 times 750. All right, that's my upper bound. And if you take a look at the lower bound, you can see if I put a 0 in here for Q squared, I'm going to get a 0. And if I put a 0 here for Q, I'm going to get a 0. So my lower bound is 0. Okay, minus 18,750. Okay, then again, this is something you evaluate on a calculator. So bring up the TI-84. And I have negative 0.01 times 750 squared plus 40 times 750. Okay, I don't need the minus 0. That doesn't affect anything, but I do need this minus 18,750. Okay, and you can see I get a consumer surplus of $5,625. Okay, so again, the evaluation bit, just type it in on a calculator. Don't do it by hand. Okay, anybody questions on example 2? If you actually did try it and you got stuck somewhere, okay, maybe you want to ask a question about where you got stuck. No? No questions? Everybody managed to get this Q to pop into existence here when you integrated the constant? I'm kind of guessing that might be where a lot of you got stuck. Okay. Well, let's take a look at the second topic I wanted to talk about today, and that's valuing a continuous income stream. Okay, so let's take a look at this. Okay, I'm assuming everybody in here has heard the term interest, okay, in the sense of financial investments. Okay, interest, if you're making an investment, is the amount of money you get paid by the person you're investing with because you're loaning the money. And that's true even when you put money in the bank. You're loaning the bank money. They take that money and they do other things with it. So they pay you a certain rental fee. Same thing is true when you take out a loan. Okay, you're borrowing money. So you get to pay the rental fee for the money you don't have. Okay, so that's what interest is. Compound interest, okay, if you think about it, if you make a deposit in an investment and you let it sit there, okay, the interest accumulates not only on your original deposit, but any interest you earn as you roll along. Okay, so compounding tends to make the interest grow a lot faster, and that's also true when you're the borrower. Okay, so I want to go over some financial terminology, okay, and that's present value and future value of money. Okay, there's what's called a time value of money because of interest. Okay, a dollar today is worth less than that dollar invested would be worth in the future because the assumption is you're going to get paid interest on it. So that dollar is going to be worth more in the future if you're investing. Okay, so present value is what the money's worth today. Future value is the money's value plus its interest, however many years in the future. Okay, and that concept of future and present value lets you compare two different investments in terms of their present value or their future value. So before I move on, is everybody okay with the terminology? Okay with the terminology? I'm imagining accounting students, you have probably heard of present and future value. Okay, but anybody else questions? Okay, so here are some useful formulas that deal with compound interest. Okay, so let's talk about some more terminology. We usually use the variable P to represent the principal, which is the initial amount you're investing, your present value. R is your interest rate expressed as a decimal, right? So 2% would be 0.02. And A of T is the amount in the account at the end of 10 years or your future value. Okay, so think of P as present value. A as future value. Okay, so in other words, present value plus any accumulated interest. Okay, so here is the formula for finding the future value of an investment, a P, okay, if you compound it n times per year. Now, normally when they talk about compounding, they won't tell you, oh, it's 6 times per year. They'll tell you, you know, usually something like semi-annually, and you have to know that means twice a year. Or monthly, that means 12 times a year. Or quarterly, that means 4 times a year. Okay, so they don't usually say n is this number. They use a word, okay, and you have to translate that into how many times per year it is, okay? And then we have this continuous compounding formula, which looks totally different. It has a P in it, but this expression is replaced by e to the RT, okay? And basically, your continuous compounding is not something a bank is going to pay you. It's usually used for investments that generate constantly, okay? So we're going to use this. You'll see how we're going to use this in a minute, okay? So again, if you're using a formula to find what an account's worth in the future, A of T is the future value. If you're using the formula to find a present value, what you have to deposit today to get a certain amount in the future, you're solving for P, okay? All right, so basically, that's what we're doing, okay? You can use it like this. You can do it backwards like this. I prefer to tell students just solve the equation for P and don't worry about negative exponents and things like that. Okay, you all can do algebra. Okay, so you can solve for one variable or the other. Okay, now there are some situations, okay, like when you have rents, okay, on a multitude of, say, apartment buildings, or you have income from a mine or a well, okay, where you get deposits flowing continuously into an account, okay, because the well is always producing. If you've got enough apartment buildings, you're constantly collecting rents, okay? So as long as you can model the flow of income, okay, with a function, you can use a definite integral to figure out present and future value of a continuous stream, because that's just going to be the accumulated value, okay? So again, here's this time value of money idea, okay, where present value of future cash flows are less than what you actually receive in the future, right? Because you've got the benefit of interest, okay? So when a company expects a lot of cash flow, okay, they basically can look figuring out the accumulated present value, and they can determine how much those future cash flows are actually worth, okay? Think about it this way. Say you own a mine or a well, you might want to insure it against some sort of a disaster like an earthquake or something like that. You need to know what it's worth in order to be able to insure it. So you need to be able to value that income stream that's coming from your investment. Okay, so here's the idea. Okay, suppose you can take money today and earn an annual interest rate of R, compounded continuously. Okay, and you have a continuous income function in dollars per year, okay, that is tracking what's coming out of your investment. Okay, then the present value of your income stream is given by this integral. Okay, so you're basically taking the function that's your continuous income stream, it's a rate function, and you're going to multiply it by this present value compounded continuously. And again, we're going backwards in time, which is why the exponent's negative, okay? Here's future value, we want present value. Okay, so that's why this is a negative exponent, right? So you've got this product of functions, okay? And we're going to integrate that from 0 up until the time we hold the investment, okay? Future value is the ordinary compound interest formula, present value times E of RT. Okay, so here, this is negative because we're going backwards. Now notice, folks, this is going to be a product. of functions. Okay, unless we get really lucky at simplifying that product algebraically, we are going to either have to use integration using substitution, if one of these looks like part of the derivative of the other, or integration by parts, okay, for two unrelated functions, okay, because we have a product. Okay, so I'm just going to make a note here. May need substitution or integration by parts. Okay, so that's because we have a product there, right? Now, when you're doing these problems, when you're doing them like for homework or whatever, just keep the functions handy, okay? You don't have to memorize any of this stuff, okay? Just keep the functions handy and make sure you're comfortable doing the integration bit. Okay, so let's look at some examples. You have an opportunity to buy a business that will earn $75,000 a year continuously over the next 8 years. Okay, assume you can earn 2.8% per year on your money for the next 8 years, compounded continuously. Is the business worth its purchase price of $630,000? Okay, so this is a real scenario, okay? You've got something that generates a continuous income stream, okay, of 75,000 annually, okay? And they're asking $630,000 for it, assuming again you have all the assets to do the deal. Is it worth it? Is this a fair price? So what do you need to do? Okay, you need to figure out the present value of that income stream, because you're going to buy it today, right? So you're going to need to figure present value of the income stream and compare it to the purchase price. Okay, so that's kind of a statement in English of what I want to do. And it's always a good idea before you just jump in to sit and think about, okay, what are they asking? Well, they're saying, is it worth spending $630,000 to buy this business today? And you know a couple of things about it. You know it earns $75,000 a year continuously for the next 8 years. Okay, and you want to know what's the value of that income stream today compared to what I can earn on my money if I invest it. Okay, so here's my present value of an income stream formula. I'm just copying this so I can see what I need in order to make it work. Okay, and this is integrated with respect to time. So I can see I need f of t, I need a function, okay? Notice they're just giving me a constant amount, okay? So my f of t is just 75,000. Okay, there's no t in there, there's no nothing, okay? I'm not going to earn more per year as years tick along, right? So there's no t in that expression, okay? Otherwise you'd get 75,000 times 1 is 75,000. 75,000 in the second year, you'd say, oh, I'd earn 150, and that's not what's happening. Okay, it's a constant, which is going to make it real easy to integrate. Okay, then I need to know my rate, R, as a decimal. They said I could earn 2.8%, so that's 0.028. Okay, the other thing I need is my upper bound on the integral, which is how many years I'm going to hold this investment, and that's 8 years. Okay, so here's big T, here's f of t, and here's r. Okay, and again, those are all the things I need to plug in. Okay, all the constants. Little t here up in the exponent is the variable of integration, so I'm not going to mess with that. Okay, now let me plug everything in. So that's the integral from 0 to 8 of 75,000 e to the minus 0.028 t dt. Okay, so there's the integral with all the bits plugged in. Okay, anybody got questions so far? Okay, either where the numbers are coming from or how I'm plugging them in. Okay, good. All right. So now we're going to put our calculus hat on because we handled the word problem bit. And now we have to integrate this. Okay, this is simply an exponential. And here's what I'm going to do. I'm going to first pull through that coefficient, 75,000. Integrate from 0 to 8, e to the minus 0.028 t dt. So I need to integrate an exponential, which is itself, except when you've got a number multiplying your exponent up here, then you've got to divide by this number. So here's the way this integrates. Okay, this is e to the minus 0.028 t divided by negative 0.028. And then I'm going to evaluate that from 0 to 8. Okay, everybody all right with the integration? Okay. So again, if you've got some constant times your variable up here, you're going to divide by that constant when you integrate. Okay, so now what I have is I have this. I got 75,000. I'm going to pull that denominator out, right? Because it applies to everything. And then I've got e to the minus 0.028 t evaluated from 0 to 8. Okay, so I just pull this out, okay, and now it's out over here as part of this fraction. I don't have to evaluate it. I can do all that on a calculator. All right, so now I have to do the upper minus lower. Okay, and remember with exponentials, you can't just throw away a zero lower bound. Okay, that doesn't disappear. All right, so here's what I've got. I've got 75,000 over negative 0.02 outside. Then I have e to the 0.028 times 8 up in the exponent minus e to the minus 0.028 times 0. Okay, so here's my upper bound. Here's my lower bound plugged in. Okay, and now it's just a calculator problem. So I'm going to get up my TI-84. And I'm going to do 75,000 divided by negative 0.02. And then I have my first exponential. Okay, that's going to be a shift on my ln. So e to the negative 0.028 times 8. Step out of the exponent minus e to the negative 0.028 times 0. Okay, in case you're wondering, this is going to be e to the 0, which is 1. Okay, so I'm just going to leave it like that. Everybody see how I've got it typed in? I'm typing it in just the way it's written. And then I'm just going to hit enter. And I get 752,568 Okay, let me make sure I did this right. Oh, okay. I lost my 8 over here. Let me type that in correctly. Okay, there you go. So let me just re-edit that. Go back and get that 8 outside my, it's not 0.02, it's 0.028. Okay, so now I have a value of 537, 548. And since this is a money amount, I'll make it 75. Okay, so this is the future value of this $75,000 a year continuous income stream. Okay, so what does that tell you about the purchase price? Should you buy the business? Should you buy? What do you think? So again, this is the present value of that income stream. And here's what they want you to pay them to buy the business. What do you think? Anybody have any ideas? You can just type a yes or a no in the chat. What do you think? Should you buy? These are the two numbers you're comparing. Okay, Gil says no. Anybody else have any ideas? Richard says no. How about the rest of you? You're not making as much money as it costs you to buy it. Couldn't have said it better myself. Okay, so basically, this number, the 537,548, that's the value of what this investment churns out today. Okay, they want, okay, like 100 grand more than that. Okay, so this is not a good buy. All right, so because the PV is less than 630,000, this is not a good buy. Okay, but you've got to understand what the present value is telling you. Okay, so I would say no, don't buy. Okay, so that's the present value calculation. Okay, this one, anybody have questions on present value? Okay, these problems are more about understanding what they're telling you, like what it means. Okay, but you can see you can use the future value of an income stream, the present value of an income stream to value a purchase price. Like, does this make sense? Should I buy this? Okay, same thing's true if you are valuing like some sort of a machine that you're gonna use to manufacture. Okay, they can give you what you think you're gonna earn from it continuously. Okay, and you can see if it's worth the purchase price. Okay, here's a different type of problem. If we plan to deposit $1,200 per year continuously into an account that pays 6% annual interest compounded continuously, what would be the amount in the account at the end of 10 years? Okay, so basically this is saying at the end of 10 years, this is a future value question. Okay, so asking for future value. Okay, because they're asking you, what would it be worth in the future? Okay, and it's the asking you for the future value of a continuous income stream. Okay, and that's this formula. Okay, and I think you can see that you've got an R value here. Okay, T here is going to be your variable of integration. What else do you need? What else are you missing? What's the other variable in this future value formula? Anybody see it? Okay, T is the variable of integration. R I have. What about PV? Do I have PV? PV is the present value of this income stream. Do I have that? No. No, I don't have it. No. This is the flow, okay? This is a continuous flow of income, okay? So essentially, what I need first is the present value of this income stream. Okay, so first, find the present value of the income stream. Okay, now it's coming from my deposits, but that's okay. All right, so that is PV equals 0 to T f of T times e to the minus RT dt. Okay, so then I need R is 0.06. Big T is 10. F of T, that's my function. They said 1,200 a year, so that's just 1,200. Okay. And that's everything I need to do this. Okay. So first find the present value. And again, if I do this, I'm going to pull through the 1,200. And then I'm going to integrate that E, which is going to be e to the minus 0.06 t over minus 0.06, evaluated from 0 to 10. Okay, so PV is going to be 1,200 times, and I can bring this out again. Then it's going to be e to the minus 0.06 times 10 minus e to the minus 0.06 times 0. So this looks almost identical to the last problem. And like that, I'm also going to do it on the calculator. All right, so that's 1,200 divided by negative 0.06 times e to the negative 0.06 times 10 minus e to the negative 0.06 times 0. Close that out. Okay, and you can see I get $9,023.77. Okay, that's the present value of this income stream. Okay. Everybody all right with that bit? That's the same as the last problem. And now I can find the future value. Okay, and that's using the future value formula from up here. Okay, so I'm going to put in my PV. And then multiply that by e to the minus, oh, this is positive now, e to the 0.06 t. And here, t is going to be 10. Little t is going to be 10 because I'm doing this for 10 years. All right, so this is just plug and chug. I don't really need to do anything else with this. So I'm going to take my 9023.77 and multiply that by e to the 0.06 times 10. All right, and the future value then is 16,442.38. Okay, so you can see with these problems, it's important to be able to read them and understand that, you know, what they're giving you is a flow. Okay, so if they say, again, you're depositing something continuously or you're earning something continuously, that's the flow equation that you're looking at. Okay, that's not a present value or a future value. Those are, you got to figure those out with the equations. Okay. Questions on this example? Questions on 4? Anybody questions on 4? Okay. I'm going to start the 5th problem. And again, I'm not sure if we'll have enough time to get through the whole thing. Okay. Everybody all right with 4 before I move on? Okay, let's take a look at 5. Suppose you have a company that's manufacturing a certain kind of machine, and they're estimating each machine will generate a continuous income stream whose rate in year T is given by this 15 minus 2T million dollars. Okay, so that's a continuous income stream. That means F of T equals 15 minus 2T. That's the rate at which it generates income. Assuming the lifetime of the machine is about 7 years and money can be invested at 8% compounded continuously, wow. Okay, find the fair market price. So again, this is asking you similarly to the business problem of whether it was a fair price. They're asking you to find the present value of the income stream. Okay, so find the present value of the machine's income stream and assume that that is going to be your fair market price. Okay. Okay, so here we don't have a price to compare it to. We're just going to see if we can set the price. Okay, so here's that formula again. Okay, and I'm writing it down so I can see what I have and what I may need. I have an F of T. They told me that I can invest the money at 8%, so that's my R value. Okay, and the other thing I need is the capital T, that's the upper bound on the integral, and that's the lifetime of the machine. So I'll say T equals 7. Okay, little t in this example is the variable of integration, so I don't need a value for it. Okay, so let's plug stuff in and see what I got. I have 15 minus 2t e to the minus 0.0 t dt. Okay, so there it is with everything plugged in. Okay, so I'm asking you guys to put on your calculus hat for a minute. And we're not thinking about the business side of this, but we're asking, how do I integrate it? What method do I use? How do I integrate this? Here's your integrand. What do you think? You got a product of things here, right? Does either look like part of the derivative of the other? I don't think so. These look like two totally unrelated functions. So how do you integrate a product of unrelated functions? How do you integrate a product of unrelated functions? Anybody have any thoughts? By parts. Yay, Miriam. Okay, so I need to integrate by parts. Okay, that's when you have two functions that are not related. Okay, the first thing you've got to decide is what's u and what's dv. Okay, and remember the rule of thumb for picking u. It says if you've got a log function, then u is the log function. Otherwise, u is the algebraic function. Okay, so that's the rule of thumb. So I don't have a log function, so I have to pick the algebraic one. Okay, and my algebraic function is 15 minus 2t. Okay, algebraic's just another name for a polynomial. Okay, so I'm going to let u be 15 minus 2t, and then dv is the other function. So that's e to the minus 0.08t. Okay, so that's the first step for integrating by parts, is picking u. Okay, and then I build my table. Remember, we did this in a tabular way. Okay, and I'm going to say, here's differentiate u. And integrate dv. Okay, and then I put my things in the respective columns. So here's 15 minus 2t. And here's e to the minus 0.08t. Okay, and you got to remember, you got to keep track of what you're doing, whether you're integrating or differentiating. Okay, so I'm going to go down the differentiate column first. Okay, if I take the derivative of 15 minus 2t, the 15 gives me a 0. And I'm differentiating again with respect to t. This is going to give me a -2. Okay, and if I differentiate one more time, I get a 0. Okay, that's taking derivatives. Okay, once you get a 0, that's when you stop. Now I have to go down the integration column and put as many rows in the table as I have for the differentiate column. Okay, so if I integrate this expression e to the minus 0.08t, I get e to the minus 0.08t over negative 0.08. Okay, and if I do that one more time, I'm going to accumulate another 0.08 that's multiplying the one that's already there in the denominator. Okay, so I'm going to have negative 0.08 times negative 0.08. That's going to give me a positive 0.0064 in the denominator, and I get the same numerator. Okay, so again, whenever you're integrating e to some number times the variable, you just keep accumulating that number that's multiplying your variable up in the exponent. You keep multiplying by that down in the denominator. Okay, so this is negative 0.08 times negative 0.08. That's where that came from. Okay, everybody good with the integration? All right, we're good with this part so far. All right, so remember, you build the table. Next step is to make those diagonal products like this. Okay, and then pull them out of the table. Okay, so I'm going to get 15 minus 2t times e to the minus 0.08t over minus 0.08. That's the first product. And again, I'm taking things on either side of the arrow and multiplying them together. Okay, and also remember, the first one's a plus, the next one's a minus, and they're going to alternate signs if I have more of those. So now I have a negative sign. Okay, and then I'm going to take negative 2, and I'm going to multiply that by e to the minus 0.08t over 0.0064. Okay, there's what I've got. Okay, and then I want to evaluate that because it was a definite integral from 0 to 7. Right, so it might be worthwhile to try to simplify things a little here. Okay, or as long as you're super careful, you can type it in just the way it looks. Okay, but it's going to be unwieldy. Okay, it's going to be unwieldy. So let me do this. Okay, I'm going to try to type it in just the way it looks in the interest of saving you some time. Okay, so I want to evaluate upper minus lower. Okay, so I'm going to take this two-termed expression here and evaluate it at 7. Okay, I probably should switch to square brackets to make it clearer what I'm doing. So this is 15 minus 2 times 7 times e to the minus 0.08 times 7. Okay, there it is with 7 plugged in. Okay, and then I need this piece with 7 plugged in as well. Okay, so there's upper minus, and then the lower is the same expression, okay, but it's got the zeros in there. Okay, so 15 minus 2 times 0 times e to the minus 0.08 times 0 over minus 0.08. All right, here's the second term. Okay, so here's lower, here's upper. Okay, I said it would be unwieldy. All right. So it's just a matter of how careful you are when you type it in on your calculator. Okay, just go slow. All right. I technically don't need these brackets around the first part because there's a plus sign out in front. I do need parentheses or brackets around the second part. Okay, I can just put them there so it looks like what I've written down. Okay, so 15 minus 2 times 7, close the parentheses, then I have e to the negative 0.08 divided by, oops, out of the exponent, divided by negative 0.08. Okay, and then minus negative 2 e to the negative 0.08 times 7. You know what? I lost my times 7 back here. I just realized in my exponent. See, this should be negative 0.08 times 7. So let me insert that. The trick with this is go slow. Okay, if you rush it, you're only going to wind up doing it over again. Okay, so there's the 7 here. Then I have the 7 here, and this whole thing's divided by 0.0064. There's my upper bound. Now I'm going to subtract, open up another set of parentheses, which I need, and that's 15 minus 2 times 0 times e to the negative 0.08 times 0 divided by negative 0.08. Okay, that's the first term, minus negative 2 times e to the negative 0.08 times 0 divided by 0.0064, close parens. And then hold my breath. And I got a whopping 4636. Okay, now 4636 is present value. Okay, but remember, it's not in dollars. Go back up and take a look. It's in $1 billion. Okay, so this is scaled by millions. Billions of dollars. Okay, so a purchase price would be about $46,360,000. Okay, you're scaling by millions. Okay, everybody okay with this? So again, this was exactly like the price calculation we did when they asked us, is $630,000 a fair price for the business? It's exactly like that. The only difference is we're not comparing it to anything, we're setting a price. So whatever comes out of this present value calculation is the fair price. Okay, so we shouldn't pay any more than 46,360,000 for this machine. Okay, based on its continuous income stream. The only other wrinkle was the way we had to do the integration. We had to do by parts because we had 2 unrelated functions. Okay, so let me ask questions on this one. This was the most complicated one. So questions on example 5. Anybody questions on this one? All righty. not seeing any. And again, I'm going to upload all of my notes with the video, so you'll be able to go over, look, follow them as examples when you're working on, the hardest part is formatting. Yes, absolutely. Formatting and keeping track of the bits. And keeping track. I totally agree. Right? So they're not hard, they're tedious. Okay. And it is error prone if you try to rush. Okay. Like I was trying to rush here and I nearly screwed up the exponent. Okay. So just take your time, go slow. All right. I'm going to stop sharing and come back to the meeting and ask you any questions on any